Okay, so now we're going to recall everything we know about complex numbers. I have the lovely definition of complex from dictionary.com below, just so we understand what it is, because it's fitting, I believe. Anyway, imaginary number. So an imaginary number is part of a complex number. It is just a piece of the complex number. And we use the unit I for imaginary numbers. So where does this come from? Well, it's what allows us to take the square root of a negative. So the square root of -1 is I. That's the definition of I, or the imaginary unit I. In this case, then, it should make sense that I squared is -1. And I cubed is -I, because I can think of I cubed is I squared times I. And then I to the 4th is just 1. And again, if I think of this as I to the 4th is I squared times I squared is -1 times -1, which is 1. Alright, now this cycle repeats then. So using powers of 4, oops, don't get too far ahead. So using powers of 4, I know that, for instance, I to the 5th is the same as I to the 4th times I. So I to the 5th would just be I. I to the 6th would be -1. I to the 7th would be I. I to the 8th is 1, and so on. Alright. Using those properties, I want you to find what is I to the 26th, I to the 137th, and I to the 215th. Pause the video and do that. Okay, so hopefully you got that I to the 26th is -1, I to the 137th is I, and I to the 215th is I. Here is a little bit of work if you want to see my thought process on how to figure those out. Okay, so then the standard form of a complex number. Well, a complex number is a number that is made up of both a real part and an imaginary part, where the real part is the first part and the imaginary part is the second part. A and B are both real numbers. This is the imaginary part because B is the coefficient on the imaginary unit I. I do want to point out that, think about our number system. So we have, whole numbers, integers, rationals, irrationals, and then now complex. Complex is the largest of those number systems, and it includes every other number system that I just said. So for example, something like 2 is, although it's a real number and a rational number, it's still a complex number because I can write it as 2 plus 0i. So that's just something to keep in mind, that all real numbers are actually a type of complex number as well, or they are within the complex number system. Anyway, standard form is when the real part is first and the imaginary unit is second. Complex conjugates. So remember, a conjugate is the same binomial but with an opposite middle term. So if I have a plus bi, then the conjugate would be a minus bi, and vice versa. Why are conjugates important? Well, similar to what we talked about recently, I think it was our last example, maybe in the last section. Similar, or close to that. But if the example I'm referring to was where we were able to eliminate a irrational number by multiplying by its conjugate. Same thing is true with a complex number. So if I multiply a complex number by its conjugate, the result is always just a real number. Principal square root of a negative number. So if I have a, which is a positive number, the principal square root, sorry, there's some glitchiness going on with the computer. Anyway, so if a is a positive number, the principal square root of the negative number, negative a, is square root of negative a is square root of a times I. Okay, that should make sense. We know that the square root of -1 is I. Why is this important? Well, it's important because when we're dealing with just positive numbers, I know that by property of multiplication, the square root of AB is the same as the square root of a times the square root of b. But this is not valid when a is less than 0 or when b is less than 0 or when they're both less than 0. So that's why it's important. Okay, so first one here, I want you to simplify and write in standard form 1 minus 2i quantity squared minus 1 plus 2i quantity squared. Perform that operation, pause the video, unpause when you're ready to check your answer. Okay, so the first thing I did was I multiplied out each binomial. So 1 minus 2i squared is 1 minus 4i plus 4i squared. 1 plus 2i squared is 1 plus 4i plus 4i squared. Remember, I squared is negative 1, so this 4i squared becomes negative 4. This 4i squared, when I distribute this negative, becomes positive 4. So now, conveniently, the 1, and the negative 1, and the negative 4, and the positive 4 are going to reduce, and I'm left with negative 8i, or 0 minus 8i. So again, in standard form, I would accept either this or this. Next one. 6 minus 7i over 1 minus 2i. Now you may or may not recall that to perform division of complex numbers, you want to multiply the numerator and denominator by the conjugate. The reason why is really when we perform division of complex numbers, all we're trying to do is to eliminate the imaginary units from the denominator. So first step is to multiply by the conjugate. I want you to finish this. So take it from here, pause the video, unpause when you're ready to check. Okay, so we should end up with an answer of 4 plus I. So once I multiply by the conjugate on the numerator and denominator, I distribute. I get 6 plus 5i minus 14i squared in the numerator, 1 minus 4i squared in the denominator. I squared is negative 1, so this is 6 plus 5i plus 14 over 1 plus 4. Combine like terms, I get 20 plus 5i over 5. Now, I want to point out, in this case it reduced really nicely, but even if it does not reduce, in order to write the complex number in standard form, you still need to split up the fraction into the real part and the imaginary part separate. Now in this case, again, it did reduce nicely, so 20 over 5 is 4, 5 over 5 is 1, so I get my answer of 4 plus I. Last one, I want you to try this on your own. There are a couple of different ways in which you can approach the problem originally because you have addition and subtraction of fractions plus complex numbers in the denominator. So pause the video, find your answer, unpause when you're ready to check your work. Okay, so the answer should be 5 over 17 minus 20 over 17i. Now, you might not have followed the exact same path I did, but hopefully you got the right answer. So what I chose to do first was get a common denominator, because in order to add or subtract fractions, that's what you need to do. Now, that does not mean you had to do that first. You could have just done each individual division separately first. I just chose to get a common denominator. So I multiplied the left term by 4 minus I on the top and the bottom, and I multiplied the right term by I in the numerator and denominator. When I did that, then I ended up with 4 plus 3i minus I squared minus 3i. The denominator was 4i minus I squared. Now I squared is negative 1, so this actually just became 1 plus 4i. The numerator very conveniently simplified to just 5. Now I did division, so I multiplied the top and the bottom by the conjugate of the denominator. So I multiplied by 1 minus 4i. Distribute, combine like terms, simplify, and I end up with 5 minus 20i in the numerator and 1 minus 16i squared. This became 1 plus 16 because I squared is negative 1, so that's how I got the 17. And again, as I emphasized on the previous problem, it is important to split up this fraction so that I have the real part and the imaginary part separate. That is a crucial component of a complex number in standard form. Alright, complex numbers. Know I to the first, I to the squared, I to the cubed, and I to the fourth. Understand the standard form. Understand when adding or subtracting, you just combine like terms. Multiplying or dividing. Dividing, you need to multiply by the conjugate. Multiplying, distribute.